Okay, you'll have to forgive my voice. I just played basketball for like 2 hours and there was like a lot of talking, a lot of yelling because in basketball it's really interactive. So I completely lost my voice today. Okay, so look, we're trying to focus on trig identities, but specifically we want to focus on the so-called half-angle identities, these guys right here. But before we get there, we got to cover some fundamentals. Like for instance, how would you find the cosine of 45? How would you find sine of this and tangent of that? Well, if the calculator runs out of batteries, here's what you can do. You can focus on the unit circle. 45 degrees is right here. And the coordinates there would say this here on a unit circle. And recall that cosine is the x coordinate. And so here is what that would equal. So you go there and you give them that. What about 5 pi over 4? On the unit circle, 5 pi over 4 would be 1, 2, 3, 4. It would be right here. And the coordinates there on the unit circle, if you look at a unit circle, would be these numbers here. So you go there, which is here, and you give them sine, which is the y coordinate, which is why your calculators would say this. What about tangent? 225 would be, well, actually, 225 would be like right here, okay? And so tangent is when you go y divided by x. And so if you go this divided by that, it would actually just be 1. One more, what about the tangent of, let's say, what about the tangent of 300 degrees, okay? The tangent of 300, well, 300 is right here, and the coordinates there would say this number here, these coordinates. And so tangent is this divided by that. When you go this divided by that on a calculator, you're gonna get this right here, okay? So this is how you do these problems. You go here, you give them that. You go here, you give them that. So what about one of our half-angle identities? What if you have the cosine of 225? Well, that's a problem because on the unit circle, 22.5, right? 22.5, you're not gonna see it. What are the popular numbers on the unit circle? 45, 60, 135, 215, 270, and so on. But where's 22.5? You're not gonna see it. It's there, but you don't see it. So the point is to use a half-angle identity. Here's what we're gonna do. We're gonna make something look like this. And once it looks like this, we're gonna turn it into that, and that's gonna be the answer. So for example, this problem here, it says cosine of 22.5. I want it to look like an angle over 2. So what I'm gonna do is this. I'm gonna put a 1 right there because I have permission to. Put the 1 in the parentheses like that. But if I want this to look like that, I have to have a 2 in the denominator. So I'm gonna multiply the bottom by 2, but also the top by 2. And so let's see, this becomes 2 in the bottom, and in the top, 22.5 times 2 becomes 45. And so now this looks just like that, where it's cosine, cosine, the bottom is 2, the bottom is 2. And so what's playing the role of theta? 45. And so once you have this, we're supposed to write that. And so this would equal square root 1 plus, well, what goes here? Cosine of whatever plays the role of theta. Here for our problem, playing the role of theta would be 45. And so how come this is better than these guys? Because I know what cosine of 45 is. We actually did it in the warm-up. Cosine of 45 gets replaced by square root 2 over 2. So this would equal 1 plus square root 2 over 2 over 2. Now, if you focus here, if you get a common denominator, this 1 could become 2 over 2 instead of 1, because 2 over 2 is 1. And now you can add those to get a single fraction, and that would be square root 2 plus square root 2 over 2 all over 2. And then these 2's here in the bottom, these 2's can actually combine to give you square root 2 plus square root 2 over 4. And then what you can do is you can actually square root the top independently, and you can square root the bottom independently, but the square root of the bottom, which is a 4, would just be a 2. So this would be your final answer, but you have to make a decision. Is your answer going to be positive or is it going to be negative? I want you to make the decision about positive or negative at the beginning of this process. At the very beginning, they said cosine 22.5. Guys, where is 22.5? Is 22.5, is it going to be in quadrant 1, 2, 3, or is it going to be in 4? 22.5 is clearly in quadrant 1. And in quadrant 1, cosine is positive. As a matter of fact, everyone is positive in quadrant 1. And because that's positive in quadrant 1, your answer is going to be positive. So just leave it like this. And that is what you want to turn into the teacher. Let's try this one here and then we can call it a day. Sine of something. It says 5 pi over 8. But if you look at your unit circle, you're not going to see 5 pi over 8. So do the same trick as before. The trick is to put a 1 beneath it and to multiply bottom and top by 2. Always multiply top and bottom by 2 because you're going to create a 2 in the bottom. And in the top, 5 pi over 8 times 2 becomes 5 pi over 4. And now we can do the identity. Whatever this is, you make it look like that instead. And so let's see, this would become sine. This would become square root. We're doing this guy, right? We're turning this into that because it's sine of theta over 2. Here, playing the role of theta is 5 pi over 4. So this becomes 1 minus cosine 5 pi over 4 over 2. Now a quick timeout. What's the cosine of 5 pi over 4? 5 pi over 4 is actually right here. Cosine is the x coordinate. So it becomes this guy, negative square root 2 over 2. So this becomes 1 minus negative square root 2 over 2 over 2. Double negative becomes positive. Do actually what you did in the previous problem. And I actually think it's gonna be the same answer, I think. So that's kind of weird that I honestly just made up these problems and they ended up being the same answer. But now you have to make a decision. Is this positive or is this negative? Well, 5 pi over 8. Where in the world is 5 pi over 8? I'm not too sure. So you know what I'm going to do to 5 pi over 8? I'm going to turn it into degrees by multiplying it by 180 over pi. If you want to turn radians into degrees, you multiply by 180 over pi. The pi's would knock out. And on a calculator, 5 times 180 divided by 8, it says 112 degrees. So where's 112 degrees? 112 degrees is going to be like right here somewhere. And then sine is positive here, right? This is the sine, right? Up here, sine is positive because sine is the y coordinate and this is above the x-axis. So I know that this guy is going to be positive. The whole thing's going to be positive. And so my answer is also going to be positive. So that's how these problems work, the half angles. Multiply top and bottom by 2, and then you're going to use your identities, and then you're going to use facts that you know about the unit circle, and then decide if it's positive or negative based on the quadrant that the original angle falls in.